This is Euclid Book 11, definition number 28. It says, a dodecahedron is a solid figure contained by 12 equal, equilateral, and equiangular pentagons. Now, how are we going to draw this thing? Now, I will go more extensively in this when we officially draw it for Euclid Book 13, proposition number 17. But here's the key to this. First of all, you have to draw this cube right here. Okay, that's the first thing we're going to do. You're going to say, well, how are we going to draw this cube? Okay, well, first of all, we're going to draw this square. You see this square right here? It goes from A to B to C to D. We're going to draw that square. And, of course, we're going to bisect all these lines here. That's why we have the bisect at G, at K, at H, and at L. Now you say, well, how do we draw the rest of the cube so it looks exactly like this? Okay. Let me show you how to do that. We're going to take this clock. See the clock? Now I'm going to take this, I'm going to place it just like this. Okay? Now then, watch this line right here. No matter how far around you turn it, you could turn it this way, you could turn it this way, you could turn it any way you want. This line is going to be exactly perpendicular to this. It doesn't matter where you turn it to. It's still going to be perpendicular to this. Alright? That's how we're going to draw this. Now again, you're saying, well, okay, how are we going to draw this? Well, we're going to take this. This is going to be AD right here. Okay? This is going to be like one of the clock hands. Now, you remember how my ink pen was standing on top of the clock hand? Okay. Well, this is going to represent my ink pen. This is the ink pen right here. This is the clock hand. All we're doing is removing the clock hand from AD to here. That's all we did. Now you say, well, how are we going to do that? Well, we're going to place our compass. The center of the circle is going to be right here at D. The outermost edge is going to be here at A. And we're going to swing it around. And this will be a point on the circle that starts at A and comes back up to here. And when you do that, and you draw this line from D to this point right here, you're going to form an exact 4-inch line at this angle, and this line right here is going to be perpendicular to this. And you saw why it's going to be perpendicular to that, because no matter what position that clock hand is, it's still going to be perpendicular to this. That's how you're going to do that. And you're going to repeat this procedure all the way around this cube until you draw that. You're actually going to draw the whole cube. But then it gets a little tricky. And let me show you why I say it's going to get a little tricky. Because we have to go back to Euclid Book 2, proposition number 11. Now, before we do, you see this line right here? It's exactly 4 inches long. From A to L is 2 inches. Remember, we have actually bisected every one of these lines. AD was bisected at L, AB was bisected at G, DC was bisected at K, and CB was dissected at H. Okay. So, once we've bisected this, we need to enforce something called the golden ratio. And this is what we're going to do. By Euclid Book 2, proposition number 11. I'm going to draw this out, and you're going to watch me do this. Okay. Again, I'm going to say we're going to do this according to Euclid Book 2, proposition number 11. We're going to draw this square. This is going to get us our golden ratio. Because what they're going to say is we need a mean and an extreme ratio. Now then, we're going to bisect this line right here. Well, obviously, half of 2 inches is an inch. And then, what we're going to do is we're going to draw this line right here, just like this. Okay. And when we do, we're going to duplicate the length of this line. Now, in order to duplicate the length of that line, and I hope you're watching here, I'm going to have to get out the good old trusty compass. Now, I know these measurements won't be exact, but they'll be very, very close. You want more exact stuff, get yourself a better compass and do the drawing yourself. I'll get it exact as I possibly can. Now, this kind of goes under the same principle as this. Okay. Now then, gotta get a pencil here. I have to draw some more arcs. You're sitting there going, really? You have to draw some more arcs? Yep. Because we have to duplicate this line length right here. And believe me when I say this is not going to be easy. Okay. Like I say, this is not going to be perfect, but it's going to be as close as I could possibly get. Okay. That's actually a little too long. But the idea is that this line right here is going to be split up now to the extreme and mean ratio. Okay? Now that that's been split up to the extreme and mean ratio, we have to do some measurements. Actually, we just have to do one measurement. And this one right here is going to be about 1 1/4. So what we're going to do, and making sure we have this exactly right, oh, come on. Alright. Now this is the extreme and mean ratio. Now we're going to have to do this for every one of these lines. This line here, this line here, this line here, and this line right here. Now why do we have to do this? Because we're going to be drawing pentagons. Eventually we'll be drawing 12 pentagons, but we're not going to draw 12 of them at this very moment. Okay? So hang on just a second. Now what we have to do is we have to draw a line from here to here, and we're going to draw this in pencil because I don't know exactly how we're going to draw this yet. Okay? But we're going to draw it. And it's going to be exactly perpendicular. Just like that. Okay? Now there's another line we have to draw, and it has to go from B to what we will now call R. This is point R right here. That's not line R, this is point R. We're going to have to draw a line from B to R. Getting the picture here? Now then. Then we have to do the same thing on this side. Alright. Now I would recommend that you draw these in pencil so you get everything exactly right. Okay? This point is going to be S. That's point S. Still getting this? Very good. Alright, now we're going to draw the perpendicular to this one as well. Let's draw it like this. Like I said, the reason we draw these in pencil is if we make a mistake, we can redraw them, and we just erase and redraw. If we draw it in ink pen, we can't erase and redraw. Okay, and this is what you're going to do. Boy, you're going to have some fun with this one. Okay, and you're going to draw another line from B to S. Ooh, that's why we draw in pencil. Neat. Alright, now as we continue the construction of this thing, we have to do some other stuff with this too. And as you'll see, we're eventually, now when I do the actual proof itself, we're going to actually draw pentagons over the cube. You can see we're starting to set up the lines necessary to draw the actual pentagon above the cube. And we're going to draw all 12 pentagons above the cube, and that's what's going to make the 12 sides. See what I mean? And that's where we're going to get into the massive proof on this thing. Whew. You can see there's going to be quite a little construction. Now, am I going to complete the construction in this particular video? No, I am not. And the reason is it's very complicated. But as you can see, the two main principles of this construction is first drawing the cube and then drawing these golden ratios right here and drawing their perpendiculars. Okay. But the reason I'm going to leave the rest of this construction for a later video is because we're actually going to come back to this and we're going to formally prove it. We're not going to just draw it, we're going to prove it. And I want to save that for the proof. But now you get the general idea how we're going to draw this dang thing. Alright. I think I'm going to conclude this video for tonight. I want to thank you very much for watching this presentation. Now that you know the definition of the dodecahedron and you know how we're going to construct it, or at least you have a basic idea of how we're going to construct it, we can finally move on with the regular Euclid proofs from Euclid Book 11. And those will be a lot easier than this thing. Okay, yes. When we get to the final icosahedron and we get to the final dodecahedron, we have to draw this stuff out the way we're going to draw it. Yeah, it's going to be fun. But, like I said, we're drawing these right angles right here to draw the pentagons above the cube and to join them together. And that's how we're going to draw the dodecahedron. Alright, I will show you that when we get to Euclid Book 13, proposition number 17. I will show you the rest of this drawing. In the meantime, you have a pretty good idea of how we're going to draw it. Alright, I'll tell you more in a future video, so I want you to stay tuned.